Tornadoes are awesome displays of nature's power. These swirling giants can form in a matter of minutes, transforming a calm day into a scene of chaos and destruction. The sheer force of a tornado is enough to uproot trees, flip cars, and level entire buildings. But what exactly causes these powerful phenomena? How do they form, and why do they have such devastating effects? They are swirling vortices of wind, created when warm, moist air meets cold, dry air. This collision of air masses creates instability in the atmosphere, leading to the formation of a supercell thunderstorm. Within this storm, a rotating updraft known as a mesocyclone can develop. If conditions are right, this mesocyclone can tighten and intensify, eventually forming a tornado. Imagine a dark funnel cloud ominously swirling in the sky. This is the visible manifestation of the tornado, a column of air extending from the base of the thunderstorm to the ground. The funnel cloud is made up of water droplets, dust, and debris, all caught in the powerful updraft of the tornado. The cloud descends from the sky, reaching ever closer to the ground. As it makes contact, the tornado begins its path of destruction. The winds within a tornado can exceed 300 miles per hour, making them some of the most violent weather phenomena on Earth. It reaches for the ground with incredible force, tearing apart anything in its path. The damage caused by a tornado can be catastrophic, with entire communities left in ruins. The aftermath of a tornado is often a scene of utter devastation, with homes, businesses, and lives shattered in an instant. Tornadoes have fascinated and terrified people for centuries. Historical accounts of tornadoes date back to ancient times, with many cultures having their own myths and legends about these powerful storms. Despite our advancements in science and technology, tornadoes remain one of the most unpredictable and dangerous natural disasters. These storms are capable of immense destruction, with the power to obliterate buildings, hurl vehicles through the air, and strip the bark from trees. The scale of destruction can be overwhelming, leaving communities to rebuild from the ground up. They leave a path of devastation in their wake, a stark reminder of nature's raw power. The scars left by a tornado can last for years, both on the landscape and in the hearts of those affected. Scientists study tornadoes to understand them better, using advanced technology to track and analyze these storms. By understanding the conditions that lead to tornado formation, meteorologists hope to improve their ability to predict these events and provide earlier warnings to those in their path. We want to predict them and protect people from their wrath. Early warning systems and improved forecasting techniques have saved countless lives, but there is still much to learn about these powerful storms. Join me as we unravel the secrets of these natural wonders. Together we will explore the science behind tornadoes, hear stories from those who have survived them, and learn how we can better prepare for these incredible displays of nature's fury. Tornadoes are born from powerful thunderstorms, but not all thunderstorms are created equal. Only a small fraction spawn tornadoes. These storms need specific conditions to form. One key ingredient is atmospheric instability. Imagine warm, moist air near the ground. Now picture cold, dry air above it. This difference in temperature creates instability. The warm air rises rapidly. It's like a hot air balloon ascending into the sky. This rising air is the fuel for thunderstorms. As warm air rushes upward, it cools and condenses. Water vapor turns into tiny water droplets and ice crystals. This forms the towering thunderclouds we see. The rising air is called an updraft. It's a key player in tornado formation. Think of an updraft as a giant vacuum cleaner. It sucks air from the surrounding environment. This creates strong updrafts within the thunderstorm. These updrafts can reach speeds of over 100 miles per hour. They are the driving force behind tornadoes. Most tornadoes come from a special type of thunderstorm called a supercell. Supercells are long-lived and powerful. They have a rotating updraft called a mesocyclone. This rotation is key to tornado formation. Imagine a supercell as a giant spinning top. The mesocyclone is the spinning part. It's like a whirling column of air within the storm. This rotation helps to concentrate the storm's energy. It sets the stage for a tornado to form. Section 5: Mesocyclones, the rotating heart of a tornado. Not all supercells produce tornadoes, but if conditions are right, the mesocyclone can stretch toward the ground. As it stretches, it gets narrower. This intensifies the spinning motion. Think of a figure skater spinning with their arms outstretched. As they pull their arms in, they spin faster. The same principle applies to the mesocyclone. As it stretches and narrows, its rotation becomes incredibly fast. Section 6. Wind shear, the sculpting hand. Another crucial ingredient in tornado formation is wind shear. Wind shear refers to the variation in wind speed and direction at different altitudes. This phenomenon plays a pivotal role in the development of severe weather conditions, including tornadoes. Wind shear is a change in wind speed or direction with height. This change can occur over a short distance or a large area, and it significantly influences the behavior of storms. When wind shear is present, it can cause the air to rotate, which is a critical factor in the formation of tornadoes. It's like a sculptor shaping clay. Just as a sculptor uses their hands to mold and shape the clay into a desired form, wind shear shapes and influences the structure of a storm. The interaction between different wind layers can create a rotating column of air, much like the way a sculptor's hands create intricate shapes from a lump of clay. Wind shear helps to tilt the rotating updraft. This tilting is essential because it allows the storm to develop a vertical structure, which is necessary for the formation of a tornado. Without wind shear, the updraft would remain vertical, and the storm would not be able to develop the necessary rotation. Imagine wind blowing from the south near the ground. This wind provides the initial push that starts the rotation. Near the surface, the wind is relatively slow and steady, but as you move higher up, the wind speed increases and the direction changes. Now picture wind blowing from the west, higher up. At higher altitudes, the wind is stronger and can come from a completely different direction. This difference in wind speed and direction between the ground and higher altitudes creates a shearing effect. This difference in wind direction creates a horizontal spinning motion in the atmosphere. This horizontal rotation is the first step in the development of a tornado. The wind shear causes the air to spin horizontally, much like a rolling pin on a table. Wind shear helps to tilt this spinning motion upright. As the storm develops, the updraft tilts the horizontal rotation into a vertical position. This vertical rotation is what we see as the funnel cloud of a tornado. This creates the rotating updraft of the mesocyclone. The mesocyclone is the rotating heart of the storm, and it is this rotation that can eventually lead to the formation of a tornado. Understanding wind shear is crucial for predicting and understanding tornadoes. Section 7. Humidity, fueling the fury. Humidity plays a crucial role in tornado formation. Warm, moist air is the fuel for thunderstorms. When this air rises and cools, the water vapor condenses. This releases heat, which further powers the storm. Think of humidity as the gasoline that powers a car engine. The more humidity there is, the more fuel the thunderstorm has. This can lead to more powerful updrafts and a greater potential for tornadoes. Section 8. Tornado Alley and Beyond, where twisters touch down. Tornadoes are one of nature's most powerful and unpredictable phenomena. They can cause immense destruction in a matter of minutes, leaving behind a trail of devastation. Understanding where and why they occur is crucial for preparedness and safety. Tornadoes can occur anywhere in the world. From the plains of North America to the far reaches of Australia, these violent storms do not discriminate by geography. However, their frequency and intensity can vary greatly depending on the region, but some areas are more prone to them than others. Certain regions have the perfect mix of atmospheric conditions that make tornado formation more likely. These areas are often closely monitored by meteorologists and storm chasers alike. In the United States, Tornado Alley is a region with a high frequency of tornadoes. This area is infamous for its regular and often severe tornado activity, making it a focal point for tornado research and preparedness efforts. This region stretches from Texas to Nebraska. It encompasses parts of several states including Oklahoma, Kansas, and South Dakota. The vast flat landscape of this area provides the perfect stage for tornadoes to form and travel long distances. Tornado Alley has the perfect conditions for tornado formation. The unique geography and climate of this region create an environment where tornadoes can thrive. The interplay of different air masses and weather patterns is key to understanding why this area is so tornado-prone. It has warm, moist air from the Gulf of Mexico. This warm air is a crucial ingredient in the recipe for tornado formation. As it moves northward, it encounters other air masses, setting the stage for severe weather. It also has dry air from the Rocky Mountains. This dry air descends from the higher elevations and interacts with the warm, moist air from the Gulf. The collision of these air masses can create the instability needed for tornadoes to develop, and it experiences strong wind shear. Wind shear refers to the change in wind speed and direction with height. This phenomenon is critical for the development of the rotating updrafts that can lead to tornadoes. This combination of factors makes it a breeding ground for tornadoes. The unique interplay of warm, moist air, dry air, and wind shear creates the perfect storm for tornado formation. Understanding these conditions helps meteorologists predict and track tornadoes, ultimately saving lives and reducing damage. Section 9. Respecting nature's power. Tornadoes are a reminder of the immense power of nature. They can be beautiful and awe-inspiring, but they can also be deadly. It is important to respect their power and take precautions. We must continue to study tornadoes. We need to improve our forecasting and warning systems, and we must educate the public about tornado safety. By understanding these storms, we can minimize their impact and save lives.